Not too long ago, I was working with a manufacturing company. They wanted to do a predictive maintenance. We were collecting tons of data, machine data, sensor data, and at the beginning, everything looked okay. But then we ran some quality checks. What we found, over 30% of that data had serious quality issues. Even worse, they had no clue. But how do you know if your data quality is good? How do you check for data quality? Or do you check it at all? If your answer to any of this question is, I'm not sure, you're not alone. That's where DQX comes in. In this session, I will cover why we built DQX, what DQX is, and how you can use it. We'll also have a live demo coming up. So just forward-looking statement. My name is Marcin Wojtyczka. If you are into sailing, you can probably judge from this picture that I like sailing. I'm a DQX co-author and contributor. I love software engineering and data engineering, and I'm senior resident solutions architect at Databricks. So with that, let me hand over to my colleague, Neha.
Hi, everyone. My name is Neha. I'm a resident solution architect with Databricks based out of London. I'm a DQX contributor. For work, I love architecting, implementing, and fine-tuning data platforms with focus on data quality. Outside of work, I love to travel. That's me, and I'll hand it over to Alex.
Hello, everyone. My name is Alex. I'm a lead specialist solution architect based in Germany. I'm co-author of DQX, and I'm working a lot on different topics, data engineering, data quality. Let's first talk why we built the DQX. Really, the story of DQX has started 4 years ago when many customers started to reach us to get the clean data in their projects, like reporting or machine learning, especially like predictive maintenance. And common requirement for many of them was that it should support not only batch, but also should support the streaming. It should have a different reactions. So like, for example, we can stop the processing of the data, we can quarantine the data, drop the bad data. We need to apply the checks on the row level or dataset level. Also, we need to provide very detailed explanation why something happened, because if you have a table with 1,000 of columns and billions of rows, you could not figure out why the things failed. One common requirement was also like to split the responsibilities between the data engineering, who know how to program the things, and data owners who know the business logic. One requirement was also like how we can speed up the development of the data quality checks, especially like, for example, if you have very wide tables. But 4 years ago, the situation was following. We didn't have anything built in on Databricks. Now, of course, we have lakehouse monitoring, we have DOT expectations, but at that time, we didn't have anything. Also, we still have some functionality in DQX that doesn't exist in built-in products. Also, we are improving that situation. In Databricks Labs, we also have a project for data quality, but it was in Scala and was not really used by customers, especially for the people who are not so familiar with programming. We tried to use open source frameworks like DQ and Great Expectations, but there were some big issues like relatively steep learning curve, not so good integration with the streaming, and also it was problems with integration, and it didn't give you the detailed explanation why the specific check failed and where. And this is why we built the DQX, and we'll pass the microphone to the Marcin to talk about DQX capabilities.
Thank you, Alex. So now that's the why is clear, it's my pleasure to introduce you to DQX. So DQX is a Databricks quality framework. With DQX, you can validate data quality of PySpark DataFrames, and it's developed under Databricks Labs. So if you don't know, Databricks Labs are open source projects that we develop by Databricks, in Databricks, by Databricks engineers, and we also have wider community contributing in. And these projects are to innovate and experiment. And most of Databricks Labs projects eventually mature into core Databricks products. So we only released it in January this year, and we've already got fantastic feedback from customers and community. We have very good adoption, over 300 customers using DQX now, close to 1 million downloads per month. And customers are using DQX for petabytes of data. And we've also been amazed by the number of videos and blog posts people are sharing about DQX. So we are very grateful for that. And there are many reasons to love DQX. You've got detailed information to reduce your troubleshooting times from days to minutes. And we cover all Spark workloads so that you don't have to think which framework to use for what, for which Spark engine. We define quality rules at row level and dataset level, so you have a choice. We provide profiling capabilities and ability to generate quality rules. And you can define the rules in code or YAML file. In my opinion, there are two critical areas in the Lakehouse architecture where it's very important to have data quality in place. The first one is processing data from the external systems, because this is the data we actually don't know, so we cannot trust it. So it's very important that we do quality checks there. So this data typically sits in the bronze layer. So before we process further, we want to make sure that the data is sane. Second use case is making the data available for consumption. So if you make any decision making, you want to make sure that the quality is good. So this data usually sits in the gold layer. And in the example here, we start with profiling. So we have the bronze layer. We profile the data, and we generate quality rule candidates. These candidates can be then refined by human that have domain knowledge. Once these checks are ready, you can do quality checking. So DQX will do quality checking, and it will quarantine all the data that hasn't passed the quality checks. If the data can be curated, we can reingest it back. And we can monitor the trends using Databricks dashboard. Now, you may ask, okay, Marcin, but which framework should I use, right? Because we have now Lakehouse monitoring, we have DLT, we have DQX. What should I use? I would say if you need reactive quality checking, that means quality checking of data that has been already processed and written to a table, Lakehouse monitoring today is a very good choice. If you use DLT, so you have DLT pipelines, your first choice probably should be DLT expectations. But where the DQX comes in, so three use cases. Proactive quality monitoring before you write the data out. So as you process the data, you want to make sure that the quality is good. Because often it's too late. Once you write the data out, it might be too late. So you want to do it proactively. Second use case is to quarantine the bad data so that it doesn't end up in the final system. And third is custom quality checks. DQX is really, really good with custom quality checking. Yeah? So if you have any custom requirements for your quality checking, DQX is very good. Now, this is a comprehensive summary of most popular frameworks for data quality. Not all. I know it's quite horrible to read, and I know it's hard to comprehend, but probably it's a good time to take a picture now. I won't go into details here, but just three things I want to mention. So DQX stands out with row-level checking, ability to quarantine data, and very good integration with Databricks, which is a big, actually, issue with other open source frameworks. Now, let's see how DQX works. So DQX can perform quality checking on PySpark DataFrames. So we get a data frame as input, and it produces two data frames out. So good data frame contains no quality issues. And bad data frame, of course, contain all the issues. So that bad data frame we can then quarantine. and issues are reported as additional columns. So you get the original data set with additional columns that will tell you exactly what has happened. For every single row, you'll get detailed log of what has happened. And it's very easy to query this as well. So if an issue occurs, in that case, in column city, so the column city is null, we run the DQX to check the quality, and it's going to be reported inside these additional columns. So you get the detailed log there. Now there is a second option. You can produce just one data frame out, without quarantining. So if you just want to do a pass over your data to check quality, you can just return one data frame out. And it's a good option if you don't need quarantining. Now, the DQX offers a number of standards built-in libraries. Of course, you can very easily build your own library or your own checks, but there is a very good set of standard built-in checks. So we have a row-level set and what we call data set level checks. So let me explain what I mean by this. So row-level checks are all kind of checks or rules that operate on individual rows. So for example, if I want to check whether a particular value in a column has issues, I would use row-level checks. Data set level checks, on the other hand, operate on a set of rows. So these are usually aggregate type of checks. If you want to check the count, statistical information, average, outlier detection, all these kind of things will be classified as data set level checks. And we are currently just adding this to the DQX. So let me show you now how to use the DQX. So you can use the DQX as a library or tool. The library provides the quality checking ability, and you can just install it on a cluster using pip, and you are good to go. So very simple. Using the DQX as a tool means installing additional things in the workspace. You do it with Databricks CLI, and you will get additional capabilities. So things like profiling job, quality checking job will be there. Now, there are multiple ways to define checks. In this example here, we define the checks in the code using the DQX classes. So we have two checks, DQ row level checks. So the first check, we check whether the column 2 is not null, and we give it criticality error. We can also give it criticality warning. That means we'll just flag this data, but it won't go into error column inside the reporting columns. Now, how you can apply it? So, okay, we have first check, and then we have the second check as well. In the second check, we check whether the value in column 1 or values in column 1 are within the allowed list. Very simple. Now, how we apply it? So we create this DQ engine. We instantiate DQ engine. We give it a workspace client, and then we just apply the check. Very simple. So if you just apply it, you get all data out with the reporting columns, original data set with the reporting column. And if you do the split, you get the good and the bad data frame. So you can quarantine that data. On the right-hand side, you can see the result. It will be for every row. If there are multiple issues, they will be reported there. So checks can also be defined using YAML. It's exactly the same. These are exactly the same checks, and the syntax is very, very similar. So in this case, we check if column 1 is null, and in the second check, we verify if column 1 is in the allowed list again, and we can apply the checks. So almost no difference there. Now, the checks in YAML can also be stored in a file or delta table, so we provide functionality to load it from a file or delta table and write it to a file or delta table. This has just been released last week. So very useful if you want to scale your quality checking. With that, let me hand over to Neha to do the live demo.
All right, so as Marcin promised that we will do a live demo, I will just do a run all here. As you can see the screen, this is a Databricks workspace and a notebook. Here I do have a cluster that got started, and I'll do a run all, saving some time. So yeah, as Martin explained that we did saw a lot of issues coming from manufacturing industry, but that's just an example that we will expand on for this demo purposes. We have taken an example of a fictional manufacturing company called Machina Metrics. Machina Metrics do have machines that have sensors that sense the environment, like it looks at temperature, it looks at vibration, it looks at compression, and take those readings. Machines also require maintenance, so the other data set that we are using for this demo is for machine maintenance, the historical maintenance information for machines. Yeah. So showing this information here, these are the two data sets that I just spoke about. Machine sensor data set. So as you can see, there is this sensor ID column, machine ID column, reading type, reading value, reading timestamp. So machine ID indicates what is a machine ID, sensors within that machine, what are the different sensors. Maintenance, the sensor type here, it could be temperature, it could be vibration, it could be compression. There are 3 different categories that we have taken here. At a particular point, like on a particular timestamp, the reading timestamp, what is the value that has been observed by machine is captured under the reading value. One important column here is the calibration date, because I'll show that to you in the data quality rules. It's the time when the sensor was calibrated on that machine, so it's a start point. And then other columns are also there. One more important column here for this example is the firmware version. It indicates that what is the middle firmware version number is. So this is a quick example of how my sensor data looks like. As you can see, there is a specific format for machine ID. There are 3 alphabets, hyphen, then 3 numbers, yeah? And sensor type is like temperature, pressure, vibration, and more things around it. This is the maintenance records data set. 2 key fields here are machine ID and maintenance ID, the first 2 columns. These are kind of primary key columns which indicate how the machine maintenance look like. Machine ID here is another important column, because we will showcase that how things, when we join the sensor data with maintenance data, machine ID becomes the join column. Why it is important that we are focusing here on machine ID is that, again, it needs to be in this format, MCH, so 3 alphabets, hyphen, 3 numbers. So quick example of maintenance table data set as well over here. You could see that the maintenance type is null for the 3rd row. So with these 2 data sets, what Machina Metrics is trying to do is to do proactive machine maintenance, which will help them to reduce the downtime of machines and increase the lifespan on machines as well, thereby saving a lot of cost. They were able to do all of this. Their data engineering team was ingesting these 2 data sets through medallion architecture. There is a bronze, silver, and gold. And then their data scientist team was having a machine learning model, which was combining these 2 data sets on machine ID column, and then predicting that are there any outliers? Are there any situations where temperature is too high, that machine will explode? And then they will send an indicator or an alert to the maintenance team that please go check, there is a problem with the machine. So they go and repair that before the problem happens. It was all going good, perfectly working fine, until a fine day when the machine maintenance team received large number of alerts, indicating that a good chunk of machines are going to explode. The temperature has shooten up a lot. So they ran to the site only to see that none of the machine was having any problem. They were cool, calm, doing their job as usual. No temperature spike was reported. They managed that situation, but then they reported it back to IT team. IT team took nearly 2 weeks of time to find out what the issue was. The DS team looked at the data. There was indeed a temperature hike, like 60,000 was the temperature reporting. Data engineering team looked at the data. They also saw a lot of spike on the data. No one knew that there was a firmware version upgrade happened that night. What happened with that is it added additional 3 zeros in the temperature column without a decimal. So that upgrade was given by the upgrade team, which was outside of the data engineering team. This is a very simple example where there are different teams playing with the data, and there is no way for the teams to know what is the problem, right? And that's where you need a tool or a framework which can ensure that the data entering into your system is actually usable, right? 60 became 60,000, 40 became 40,000, machines will explode, right? So on this point, Machina Metrics knew that they have an urgent need to find out a solution which can solve their 3 core problems. One, which can proactively identify these kind of quality issues so that they don't enter inside the system, so that they have good data and they can make good decisions. 2 is the time. Remember I said that IT team took 2 weeks of time to find out what the issue was. They needed something that can help them reduce this time so that they can figure out these issues sooner. I'll show how DQX help you over there. And the third and most important one is that it should be extensible enough so that no matter which industry you are into, think from not just from the manufacturing industry, from any industry, because this is a DQX framework we are talking about. It should be extensible enough to any quality rule that you're bringing in, right? Should not be sticking to what we have developed for you, what we have concluded as a field engineering experience. It should be beyond that. So should be extensible enough to adapt to any quality rule that you want to bring in. So these are the 3 primary things they were looking for. Let me show you how DQX helped them. So yeah, as Marcin showed to us earlier, that there are different ways of installing, using, and applying the quality rules. I'll show you the first part of it. I'll deploy it as a library. I'll apply it on Spark DataFrame, and I'll define the quality rules as a YAML file. You can do all of that in the second column as well. So there were 2 key points where DQX can definitely help you, the profiler and the quality checking. Before I show you further, one more situation happened with Machina Metrics. They thought, okay, we have the DQX framework, all good to go, but we don't know the quality rules for our maintenance data. What do? Should we wait for 2 more weeks to find out what quality rules to apply? No, you don't have to do that. DQX comes with rule inference capability, where it will look at your data and it will generate the quality rules for you. So you do have a start point. You don't have to wait for a long period to find out what is a good quality rule for you. So let's have a look. Here I have installed DQX as a library. This is one of the way that Marcin showed to you. You can deploy it as a workspace tool as well, but this is the easiest to get started. Yeah. So library has been installed. I have restarted the environment. These are some of the parameters to indicate where are we. So as I said, team doesn't know what quality rules they want to apply. What do they do? So here you see we have DQ profiler and we have DQ generator. Both of these are coming from the DQX platform. It will profile your data and it will generate the quality rules for you. So here we have instantiated DQ engine calling the workspace client. This is the maintenance data set that I showed you in the start of the session. And after I have instantiated these engine and the workspace client, we have applied the profiling. So profile your data to know how does it look like, right? Are those integer columns? Are there upper limits, lower limits, and more things like that? Then it generates the rules for you. So generator generate those rules based on the profiles. Both of these are done. Let's see, are the rules already generated or not? Is it just me saying that, yeah, everything is looking good? So yeah, these are the checks. I just have printed these for our review. So as you can see, this is a check 0, check 1, check 2, and more checks like that. Know that I did not define these rules. These are the inferred rules, right? This is a common structure. This is what DQX expect as a YAML file. So you do see there is a column called maintenance ID. Remember, this was a key column, which should not be null. So you define what column you want to apply check on, what function you want to apply, what quality rule you want to apply. Is it an error? Like, is it a kind of a rule without which your data doesn't make sense? You define it as error. If it makes sense, but you still want to track it, warn is the other way of it. And then this is an output. I'll show you where it is being used. But with this, we conclude that DQX can profile your data and can generate quality rules for you to get started. Now, you do have 3 destinations to save these rules because it has done the inference, but you do want to do a review, right? So you can save it as a delta table. As Marcin said that we just released this. It makes things much easier because most of the people are familiar with table-based structure to store the information. You can store it as a workspace file as well as a local file. So there are these 3 options that we just saw. Here, as you can see, I have saved the checks into a workspace file. And here, I have saved it into a delta table. Yeah. So both of these are executed. Now it's time to apply these checks. So remember, we saved it as a workspace file. Yeah. And then we are loading those checks from the workspace file. You can do the same for the delta table as well. You can read it from the delta table as well. Okay, so this is how the checks were applied. You have applied on the input data, the quality checks that got generated, and this is the bad data that got generated. So as you can see, I showed you that maintenance type was null, and that's why a row has landed into a bad data zone. So moving to the next section, sensor data. We just saw that rule inference is possible with DQX. You don't have to have your rules already. Now this is another part, the sensor data set. There they knew that what kind of rules do they want to apply. They know that there is a complete, one important thing here, on the left-hand side, I have given some business terminology that when business comes to you, what kind of rules do they ask you, right? I want my data to be complete before consumer use it. I need this to be following the timeliness check. I need it to be in a particular domain. I want to make sure that the format is standardized. We often hear data harmonization problem, right? So it should be harmonized between the two ecosystems. In this example, I said that they're joining sensor data with maintenance data on the machine ID. So machine ID should be similar between the two ecosystems. That's why a format standardization is required. Timeliness here, the sensor reading timestamp, the time when it is reading the value, it should not be in future. It should be either current or the past date. So we will validate whether timeliness is matching or not. And then the correctness check, that when the sensor was installed, the reading timestamp should be after that. It cannot be before that. Have a look to the YAML file. How do we define that in a YAML? So this is the YAML. How do you define this? Extending to what Marcin showed to us. This is the block that you will see for all the checks I want to apply. Completeness check, as I said, machine ID and sensor ID are two important columns. Those cannot be null. So that sits at the top. I say if those are null, my data is not usable. So I say it is an error criticality. What rule I want to apply? There are a good number of rules that we have already built for you, which you can just use out of the box. We can extend that further. I'll show that in a minute. This is another beautiful thing that we have added recently, is that you don't have to repeat the same quality rule for every column you want to apply that rule. If you have more than one column, you just mention all of these here. So it's like a clean YAML file that you are having, right? You are not repeating. In this case, I want to apply the same rule to both sensor ID and machine ID. That's why I've specified them here. The next check is around filter and range check. Remember I said there is a column called reading type. It captures temperature, vibration, and compression. I want to do a check. If temperature is the reading value, then it should not be beyond 100. So it should fall between 0 and 100. How do we do that? We just use this additional parameter here called filter. So sensor type is temperature. Then it should fall into a range. Yeah, this is a good example. You don't have to do explicit filtering and then applying the check. You just specify it here. Then I said machine ID should be harmonized between the two data sets. It should follow a particular standard. So this regex check allows you to validate whether there are 3 alphabets and then followed by a hyphen by the 3 digits. You specify it this way. Timeliness check is not in future. My reading timestamp should not be in future. So this function is already available into the framework. You can simply plug and play. The last one, which is my favorite, is a SQL expression. Why it is my favorite is because regex and SQL expression would probably cover 95% of the quality checks you do want to apply. So you don't have to rely on the checks that we have built for you. You can simply do whatever you want to as a SQL expression. So in this example, the sensor calibration date should not be beyond the reading. Like it should be calibrated or installed first before it starts taking reading, right? So that is how you specify what is the rule you want to apply, and then what is the error level check, what is the expression type. So with SQL expression, you can define any kind of SQL expression that you want to apply as a quality check. So with all these rules that we have looked at, let's go and read this file. This is the table that holds the delta table data for sensor. I have loaded this file from Workspace file using DQ engine. You could see this is sensor DQ rules here. And then we have applied the checks. Marcin showed you that you do have 2 possibilities. You can segregate the good data with bad data, or you can keep them together. For this example, I have segregated good data with bad data. So I've only used a simple rule, a simple method here, apply the checks by metadata and split my data frame into good and bad. This is your input data frame, and these are the checks that we just saw. And it is generating these two data frames. Let me show you the quarantine TF. So you do see there are 13 rows which are into bad zone. Now, interesting thing, it has arrived into bad zone, but what is the problem with these two? We promised that we reduce that time, that 2 weeks time, to a very small time to find out what the problem is, right? So let's scroll to the right. That was your original data frame with these two reporting columns at the end. These gets added to your data set, which helps you to query what is the problem. So if I expand on this, it is structured this way. So it says that machine ID is null or empty for this row. And this is the first check that got failed, right? This helps you to know what is the problem just by looking at these reporting columns. If I go a bit down, for an example, this, or maybe I want to show you where 2 checks has been failed. Let me see. Sorry, it looks like to the end. Okay, I think maybe I just show this. No, yeah, there we go. All right, so if you look at row number 6, there are 2 elements that are showing up. Machine ID is null or empty, and second is reading timestamp is in future. Yeah, it means that you are able to find out an issue with the row at the column level. So it is not the case that it will only capture your first issue. It will capture every single issue that you have in the row, which is not matching to the quality rule you have defined. Yeah? So you don't have to worry about or writing those complex where conditions to find out where the problem is. If I scroll to the left, here we see that the machine ID is missing, and then the reading timestamp is in way too ahead in the future. It is not today, 2026, for the next TIEs. Yeah, so what we just saw is that we were able to segregate good data with bad data, and we were able to see the reporting columns in terms of error columns and warning columns. There are 2 reporting columns out here, error and warning. I said 2 criticality levels. So you can decide whether, if your data set have a lot of errors, is it really useful for the consumer team to really use it? If it is warning, you can identify the issue and refix it and re-ingest it. So that is the thought that we had to have these 2 reporting columns in here. Okay, so far loving DQX with me. Start using it right away on your mobile. Okay, not on mobile, maybe on the workspace. Okay, so we are not just limiting it here. With SQL expression and regex capability and all the data quality rules that we have already built, if you're still left with a question from a business user, I have a very complex check for you. Do it with DQX. You can still do that. You can bring your own rule, or you can build your own rule. We were just arguing whether we say BYOR or we say build your own rule. Okay, so for this example, I have said that from my story, the firmware version upgrade that did that blunder of 60 to 60,000, missing the decimal. I want to ensure that when the data is coming, my firmware version is starting with V. It should not be anything else. So here we are looking at custom rule development, pretty simple. You just define what rule you want to apply. It's a very simple Python function. In that function, you define what does the rule looks like, right? Here we are saying it should start with V. It should not be anything else. So you define what rule you want to apply, and then you import this DQX make condition method, which will allow you to pass this expression to DQX, and DQX would adopt to it. So this is number 1. You have defined what check you want to apply. Then you add it to the YAML file. So this is my, all right, this one. Yeah, perfect. So everything else is exactly same as I showed you. Not really. Let me, okay, 1 second. That's okay. Okay, let me try to show that you afterwards, but what will happen with that is you will add an extra block that will tell that what column you want to apply data quality check on, exactly same structure, and you define what naming you want to apply. That's the only change we will do the YAML. So let's go back. We have defined the rule, we have defined or configured it into YAML file, register it, and then execute it. Yeah, so we are loading this from the custom YAML file and then executing it. This is the registration part. So let me summarize it this way, 4 steps. You define what rule you want to apply, add it to the YAML file, register it, and use it. That's it. So we added it to YAML. This is how you register the check you want to apply, and then you simply apply that into the same function. How do you apply? You specify what check you want to apply, apart from the check that you already mentioned. So we do have a quarantine data frame. I do love segregating my good data with bad data all the time. So if you look at this, the data that got generated as a quarantine, there is this row which has, yeah, there we go. This is the firmware version, which does not start with V. So if I scroll to the right, as you can see here, there are two issues that it has captured. The calibration date is before the reading timestamp, and then the second part is the one that we just built. Firmware version is not starting with V. So we do see that we are able to add new checks as well. You are not limited with what we have built. Last but not least, this is all good for developers. What about my business team, or what about my execs who want to see is the data quality good or not in a visual way? I don't like Python to run my code and see what the problem is. So we have built this dashboard for you as an output. It's in an early state of maturity, but yeah, it do capture how does your data set look like, and then you can decide whether it is good enough for the consumers to consume. In my opinion, if it is showing me 75% of errors, maybe it is not usable. I want to stop my pipeline right over there. And then the right-hand side, it also go to further grain to tell you what is the error. Out of that 75%, which particular field is contributing to that error. You can decide if machine ID is null, then it's an orphan record. A lot of orphan records doesn't make a good data. So you want to stop over there. So with this, I conclude the demo. I summarize it this way. We just looked at DQX. We installed it as a library. We were able to do inference. We segregated good data with bad data. We were able to extend it. We were able to bring your own rule. And then we looked at the dashboard that helps you to see whether it's in a good state to go to consumer or not. With that, I concluded and pass it over to Masin.
Okay, thank you, Naya. So there will be even more reasons to love DQX in the future, okay? So we've got a long list of features that we want to add, such as dataset level rules, quality summary, outlier detection, automatic curation of curated data, and data quality rule configurators, so that even business can configure these rules. And if you have any new ideas or you want to discuss any DQX topics, feel free to engage with us on GitHub or Databricks community site. We'll be more than happy to hear your feedback and thoughts. And we are also looking for contributors. So if you are interested in contributing to this project, please feel free to visit the site and familiarize how to do it. Now, some links for reference. We've got GitHub repository, PyPy package, documentation, and some YouTube videos. And with that, now I just want to take a moment to thank everyone on the team for making this project a reality. So none of this would be possible without you. So thank you, Alex. Thank you, Naya, Gergo, Serge, Pratik, Ivan, Thomas, Gergo, Janan, Dinesh, Sundar, Kartik, and Ginia, Jason, Casey, Jacqueline, Gagan, Christoph, and Anton. With that, we are now ready to take questions. Thank you.